Hi, my name is Brandon Gracely. I'm a high school math teacher. We're going to do some review of some basic triangle features. Remember, triangles look like these, and sometimes we will label the vertices, these corners, with letters like this, A, B, C, and the opposite sides will often use the same lowercase letter, A, B, and little c. One of the biggest and most important features is that A plus B plus C equals 180. Well, let's be really careful here. What I really mean is that the angle A plus the angle B plus the angle C is 180 degrees. Although if there's only sort of one angle to refer to, usually we mean this one right here inside. If you want to be really, really picky, sometimes you have shapes like maybe this one here. This is not a triangle, but it's two triangles. And maybe this is A, B, C, D, and I want to refer to this angle right here. Well, I can't call it just B because you don't know which part I mean, so I might call it angle CBD, or from the other direction, angle DBC, and then you'll know which angle I'm referring to in there. Anyway, the most important thing to remember here is that the three angles of a triangle always add up to 180 degrees. And so we have a bunch of kinds of triangles. We can classify them according to two different criteria. So one of those is the maximum angle. If the maximum angle is fairly small, less than 90 degrees, we end up with an acute triangle. It means that all angles are strictly less than 90 degrees. So you can't even have a 90, they got to be less than 90. Okay, and then the next one would be the right triangle. A right triangle has one angle which is equal to 90 degrees. You can't have two angles to be equal to 90 degrees because if you had one angle that was 90 and the other angle was 90, like this, you couldn't connect into a regular triangle. So that doesn't happen. These guys look like this. Oh, you can't see that. Let me draw it under here. There we go. There's a right triangle. The acute triangle looks something like this. You can't have any big angles, all small ones. And the last one is the obtuse triangle. This is one where you have at least one angle, well, exactly one angle, which is strictly greater than 90 degrees. And you can only have one like that because once you have it, you got to kind of connect the other two arms of the triangle, and there isn't enough room in your 180 degrees to have two that are greater than 90. So those are the three ways to classify according to maximum angle. Another way to classify them is according to how many angles or sides are equal. So we got three here that I'll show you: the scalene, the isosceles, and the equilateral. Okay, so the scalene one is like this. All of the angles and sides are all distinct. Angles and sides. So three different lengths of sides, three different angles inside of here. The isosceles one looks something like this. You might have two that are the same and one that is different. So you have two that are the same or equal. And that's true for both the sides, which we use a little tick mark to show which sides are equal, or you might use two tick marks. You have to use the same number though. And it's also true for the angles. So these angles right here are equal angles. And so it's the two angles that are on this last remaining unequal side that are always going to be equal in an isosceles triangle. And the equilateral one is a lovely triangle that looks like this. All three sides are the same. All three angles are the same. All three are equal. The sides, well, I guess the sides are all the same. The angles are all the same, and therefore they must be equal to 60 degrees. So how does this help us? Well, let's say you have a triangle like this one here, and you have a couple of angles that are given, but you need to find the remaining angle. And we'll call this triangle ABC. So find A. So angle A plus 51 degrees is equal to, didn't quite get there, plus 90 degrees is equal to 180 degrees. So there are the three angles. 1, 2, 3. This one here, 1, 2, and this one is the 90-degree angle. We use a little square to show that. And so that, when you simplify that, you get that A must be equal to 39 degrees. And these happen a lot, these right angle triangles. And so these remaining two angles must also add up to 90. This is 90, and then the one angle up here is 90. So you get used to coming up with two things that add up to 90. 51 plus 39 is 90, and you get to solve these pretty quickly just in your head. So that one's a right triangle. We're given two angles. Find the third angle. Let's do this one here. Let's say something like this. And this angle is given as 120 degrees. And then you need to find this angle, which I'm going to label with theta. That's a Greek letter. The angle theta, well, we've only got one angle that's given, but this is an isosceles triangle with two sides the same, and therefore two angles the same. This angle must also be theta. So I know that theta plus 120 degrees is 180 degrees. And so now I can simplify. On this side I'll have 2 theta. On this side I'll have 180 minus 120, which will give us 60 degrees. And dividing both sides by 2, then I get that theta equals 30 degrees. Okay, so we were able to use the isoscelesness of this triangle to help find that value. Just to show you a couple of other Greek letters that are often used, we have alpha, which looks pretty close to an A, beta, which is like a B with a tail, gamma is sort of like just a loop. Those are the kind of three most common ones. And then theta, and there's also a capital theta, which is kind of fatter. I probably should be using the lowercase one for all these angles. Okay, so let's just do a quick recap. We know that the angles always add up to 180 in a triangle. There are acute, right, and obtuse triangles, depending on the maximum angle. And there are scalene, isosceles, and equilateral triangles, depending on how many sides and angles are equal to each other. I hope that helps, and let me know if you have any questions.